So it comes in the category of vinyl fibers. In the vinyl fibers, different fibers are considered. So most of the vinyl fibers are the polymers or copolymers of vinyl cyanide. Most of the vinyl fibers either are the polymers of vinyl cyanide or copolymers of vinyl cyanide. Vinyl cyanide or vinyl acetate or vinyl alcohol or vinyl chloride or vinylidene chloride and tetrafluoroethylene. So these are the different categories, further categories of vinyl fibers. The broad name is vinyl fibers. So in the category of synthetic fibers, we have one category that is vinyl fibers, and the further category of vinyl fibers are the polymers or copolymers of vinyl cyanide, vinyl acetate, vinyl alcohol, vinyl chloride, vinylidene chloride, and tetrafluoroethylene. So these are the further categories of vinyl fibers. And here we have some important vinyl fibers. In this table, we are indicating some of the important vinyl fibers or the fibers which comes in the category of vinyl synthetic man-made fibers. So at the left side, you can see here the chemical name of the fiber, and here common generic name, the popular name which is used in the industry or the generic name used in the industry, that is given here. So if we take the chemical name polyacrylonitrile, then the fiber is named as acrylic or orlon. So acrylic or orlon fibers are having the chemical name is polyacrylonitrile, or the chemical used is polyacrylonitrile. Similarly, copolymers of polyacrylonitrile, then it is known as mod acrylic. Polyvinyl alcohol fibers, their name is curolon or vinyl. Polyvinyl chloride category, it is Vignon and Rovell. Copolymers of polyvinyl chloride, it is dinyl and cardilon. Polyvinylidene chloride, Saran and Villon. Polytetrafluoroethylene, the name of the fiber is Teflon. So these are the generic name of the fibers, and these are their chemical base. So acrylic is made up of polyacrylonitrile, mod acrylic is made of copolymers of polyacrylonitrile, like that. Teflon is made of polytetrafluoroethylene. So this is about the chemical name, and the generic name of the fibers comes in the category of vinyl fibers. And among this category, acrylic and mod acrylic fibers are most important fibers in this group. So if we take all these groups of fibers, the most popular textile fibers are acrylic and mod acrylic. Now, what is polyacrylonitrile fibers, which the chemical name is polyacrylonitrile and the generic name is acrylic. So here we are taking introduction about the acrylic fibers. So now we will focus mainly on the acrylic fiber, that is based on polyacrylonitrile, and which is made up of either polymer or copolymer of vinyl cyanide. So polyacrylonitrile fibers or acrylic fibers, vinyl cyanide, which is more commonly known as acrylonitrile. विनाइल साइनाइड, जिसको हम एक्रिलोनाइट्राइल के नाम से भी जानते हैं, is the raw material which can undergo addition polymerization to form polyacrylonitrile fibers like acrylic or orlon. So try to understand this line. I'm repeating it again. What is the raw material for polyacrylonitrile or acrylic fibers? The name of the raw material is vinyl cyanide, which is more commonly known as acrylonitrile, जिसको हम acrylonitrile बोलते हैं commonly, but the chemical name is vinyl cyanide. And this vinyl cyanide is the raw material for acrylic fibers or polyacrylonitrile fibers. And another thing which is important in this line is addition polymerization. So this is the fiber which we have taken earlier, or in the category of man-made fibers, which are based on condensation polymerization, but this fiber is made by addition polymerization, means no other substance is liberated during the polymerization reaction. Just the monomers are adding on continuously and forming a macromolecule, a long chain of the polymer. So this is comes under the category of addition polymerization. So two important things in this slide is name of the raw material is vinyl cyanide, जिसको हम एक्रिलोनाइट्राइल बोलते हैं, और ये एक्रिलोनाइट्राइल it goes through addition polymerization to produce a polymer of polyacrylonitrile, which is known as acrylic. And here the reaction is shown: CH2CHCN, which is vinyl cyanide. So number of molecules of vinyl cyanide when going under addition polymerization are forming a macromolecule of polyacrylonitrile, and this is known as polyacrylonitrile. So in this way, we have the introduction of acrylic fibers. Here we have something about the chemical nature or the structure of the fiber. So the structure of fiber is shown here by two molecules. One molecule is shown here. This is CH2, CHN. Unmuted. Who is unmuted? Please mute yourself. All the students are requested to keep themselves muted till that it is not required. CH2, CHCN, CH2, CHCN. So number of CH2, CHN, CHCN, that is vinyl cyanide monomers are joined together forming a macromolecule, which is shown here. Another macromolecule is shown here. And the adjacent macromolecules are firmly bound by hydrogen bonds, which can be seen here. This is these these dots are showing the bond which is formed between these two macromolecules. So the adjacent macromolecules are firmly bound by hydrogen bonds between hydrogen, here the hydrogen of and hydrogen and nitrogen. This hydrogen, when coming close to nitrogen of another one hydrogen of one molecule, is coming nearer to nitrogen of this one macromolecule. So between this nitrogen and hydrogen bond is formed. And due to very strong links, because number of hydrogen bonds are formed in this case, at all the places number of hydrogen bonds are formed. So due to very high number of these hydrogen bonds, strong links are formed, and that's why polyacrylonitrile cannot be melt spun, because it is having very strong links. So melting is not easy, and that's why this fiber cannot be spun by melt spinning method. In nylon and polyester, we have seen that those two fibers, nylon and polyester, can be produced by melt spinning, whereas this acrylic cannot be produced by melt spinning method. The solution of polyacrylonitrile in dimethyl formamide, DMF, that is the name of solvent which is used for solution spinning. The solution of polyacrylonitrile is the polymer of the acrylic fiber. So this polymeric material is dissolved into solvent which is named as dimethyl formamide. So remember, dimethyl formamide is used as a solvent, and polyacrylonitrile is the polymeric material. So when this polymeric substance is dissolved in DMF, we are getting the solution. And this solution sorry, थोड़ा सा the solution of polyacrylonitrile in DMF could be spun into hot glycerin if we are using weight spinning method, or into a cell through which hot air or gas is passed if we are using dry spinning. This paragraph is very important. I'm again repeating. The solution of polyacrylonitrile in DMF, dimethyl formamide, could be spun into hot glycerin if we are using weight spinning method, or into a cell or a vertical column through which hot air or gas is passed. So here in the bracket I am using weight spinning, because when we are using this hot glycerin into a coagulation bath, then it is known as weight spinning method. Or here when we are passing this into a cell through which hot air or gas is passed, it means we are evaporating the solvent, and this is dry spinning. So meaning is, ये जो एक्रिलिक फाइबर है ये दोनों मेथड से प्रोड्यूस किया जा सकता है. One is weight spinning method and another is dry spinning method. So this is the only fiber which can be produced by either weight spinning or by dry spinning. Any one method of solution spinning can be used to produce this fiber. Is it clear? So solution of polyacrylonitrile, the regular arrangement of polyacrylonitrile, which is shown here, it is a very regularly arranged polymer. So the regular arrangement, just a second. Sorry, there was a disturbance. That's why I took a break. Yeah. Solubility of polyacrylonitrile, the regular arrangement which is shown in this chemical nature here of polyacrylonitrile macromolecules can be disorganized at certain places by incorporation of small amount of another monomer like vinyl acetate, vinyl chloride, methyl acrylate, acrylamide, or styrene, etc. These can be uh, incorporated with the macromolecule to disorganize this organized structure. And why we are doing this? This disorganized regions have certain advantages. हम ऐसा क्यों कर रहे हैं? To achieve these two advantages. One is such polymers dissolve in solvents easier than unmodified polyacrylonitrile. Means the organized part of this polyacrylonitrile is cannot be dissolved into the solvent easily. So it is made, or it is disorganized by incorporating small amounts of another monomers like vinyl acetate, vinyl chloride, etc. So first object is, or the first advantage is, such polymers dissolve in solvents easier than unmodified. जो decomposed और disorganized molecule है वो easily dissolve होता है as compared to organized. That's why it is disorganized. Another one is become more receptive to dyes. Means the textile materials can be easily dyed if we are using this disorganized polyacrylonitrile. So due to these two reasons, these two advantages, this regular arrangement of polyacrylonitrile macromolecules can be disorganized. Here we are taking two important fibers and definitions of these two important fibers in the category of polyacrylonitrile fibers. One is acrylic fiber. Acrylic fiber can be defined, or it is made by polymerization, the fiber which is made by polymerization of a mixture containing at least 85% of acrylonitrile and the rest consisting of other vinyl monomers. So try to understand this definition. Uh, the acrylic fibers are made up of, or are made by polymerization of a mixture containing at least 85% of acrylonitrile. So अगर जो हम मैक्रोमोलिक्यूल जो ले रहे हैं उसके अंदर अगर 85% एक्रिलोनाइट्राइल हैं तो हम इसको बोलेंगे एक्रिलिक फाइबर्स. 85% से अगर कम है तो it cannot be defined as acrylic fibers. Then it will be defined as mod acrylic fibers. The mod acrylic fibers are the copolymers made from less than 85% and more than 35% acrylonitrile. So in difference in acrylic and mod acrylic is basically of percentage of this acrylonitrile. So in case of acrylic fibers, 85% acrylonitrile, minimum 85% acrylonitrile अगर है मिक्सचर के अंदर, में जो हम पॉलीमर्स और कोपॉलीमर्स ले रहे हैं उस मिक्सचर में अगर 85% एक्रोनाइट्राइल हैं तो हम उसे एक्रिलिक बोलेंगे, और अगर 85% से 35% के बीच में है दैट इज नोन एज मॉड एक्रिलिक फाइबर्स. Now raw materials, as we have seen, vinyl cyanide is the raw material. So here we are indicating three methods of manufacturing of raw material. One is acetylene route, another is ethylene route, or third one is propylene route. So any one method can be used as a raw material, and also you can remember any one method for the examination purpose. So first route is acetylene route, which is the easiest route. Hydrocyanide is reacted with acetylene. Here you can see this acetylene is reacted with hydrogen cyanide at a particular temperature, that is 80 to 90 degrees centigrade. So we are getting CH2CHCN, which is known as hydrocyanide, this acrylonitrile. And cuprous chloride in HCl or ammonium chloride is used as catalyst for this reaction. In ethylene route, here ethylene is oxidized with air and we are getting ethylene oxide, which is reacted with hydrogen cyanide at 55 to 60 degrees centigrade in presence of diethylamine. We are getting ethylene cyanohydrine, which on further dehydration at 300 degrees centigrade in presence of activated alumina, it gets converted into acrylonitrile. That is a raw material for acrylic fibers. And third is propylene route, in which propylene is oxidized with ammonia in presence of air and in presence of bismuth or molybdenum as catalyst at 400 to 500 degrees centigrade and 1 to 3 atmosphere pressure, it results into acrylonitrile. So acrylonitrile, which is raw material for acrylic, can be produced by using these three routes or three methods. After manufacturing of raw material, the next step is polymerization. As in the case of all the man-made fibers, first manufacturing of raw material, second one is polymerization. So acrylonitrile, AN means acrylonitrile. Wherever I have written AN, it means that it is acrylonitrile, name of the raw material. So acrylonitrile is polymerized by free radical mechanism involving the use of free radical initiators using oxidation reaction or decomposition reaction. So by this reaction, they add on and activate the monomer, which acts on another monomer unit, forming a linear polymer with a terminal initiating radical capable of further polymerization. Meaning of this paragraph is, यहाँ हमने acrylonitrile से शुरू किया और we are using some radicals, free radicals, which is indicated by X 0. So X in this one is indicating the first. So we are getting AN X0. So we are having the free radicals at the end. Then again, we are taking another monomer of acrylonitrile, which is joining with this. So we are getting two monomers are joined together, acrylonitrile, and again we have free radical. So this free radical is having the capacity to add another acrylonitrile monomers. And in this way, this is a continuous process. This adding on of these monomers in the macromolecule chain is going on continuously, And this is known as addition polymerization. With the help of addition polymerization, which is done by free radical mechanism in case of acrylic, we are getting polyacrylonitrile at the end. Azo compounds, benzoyl peroxide, persulfates, ultraviolet light, and gamma radiation may be used as source of free radical. Any one of from these can be used as a source of free radicals, which are useful in this polymerization reaction. Solution or dispersion in water technique is used to control the polymerization. To stop this reaction, solution or dispersion in water technique is used. And details of this free radical mechanism and solution or dispersion techniques you will study in coming semesters in fiber science. Here we have just taken the introduction. Now here we are taking two methods of spinning. One is dry spinning, another is wet spinning. So in dry spinning, we are having the dried polymers, this polymeric substance, which is polyacrylonitrile, dissolved into dimethyl formamide, which is the name of solvent. So by dissolving it into this, we are getting solution, which is having 20 to 30% weight of polymer. And then this solution is filtered and deaerated, as in the case of viscose and acetate we are doing. Similarly, here it is filtered and deaerated. Filtration is done to remove uncooked particles. Deaeration is done to remove air bubbles. Then it is fed through a pump through the spin rate, which is having 200 to 600 holes or orifices. At 80 to 150 degrees centigrade, we are getting fine streams of solution. These fine streams are passing through a column, vertical column, where we are circulating hot air at 230 to 260 degrees centigrade. So what will happen? This dimethyl formamide, which we are using as a solvent, is evaporated. And when it is evaporated, this dimethyl formamide having the melting point 153 degrees centigrade, so it gets evaporated at higher temperatures. And finally remaining behind is the filament of acrylonitrile, polyacrylonitrile, that is known as acrylic. So here solidification is done, and after the solidification, it is wound onto the take-up roller with the help of take-up mechanism in the required or suitable package form. So this is brief about the dry spinning method. And in wet spinning method, solution which is having the concentration of 10 to 25% of polymeric material uh, pumped through spin rate after filtration and deaeration. This spin rate is having more number of orifices, that is 1000 to 3000. And now this spin rate is impregnated into the coagulation bath, and the coagulation bath is containing water, glycol, butyl alcohol, calcium chloride, and kerosene. The composition of this coagulation bath, and it gets solidified. After solidification, this we are getting the filament of acrylic by wet spinning method, which can be wound onto a suitable package or can be converted into fibers according to our requirement. And these two methods, dry spinning method or wet spinning method, which is used for as a manufacturing or spinning method for acrylic, are shown here by flow chart. And here we are taking the diagram. So this diagram is indicating that acrylonitrile, which is monomer, and we are adding vinyl monomers here, catalyst, activator, and it is in an autoclave. It is heated in an autoclave, which is known as polymerizer. Asmit, please mute yourself. Asmit Singh, mute yourself. Then polymerizer. So here polymerization is taking place, which is addition polymerization, which we have already taken. And then here we have a solution vessel. After polymerization, it is dissolved into a solution. So in the, here we are getting a solution. It dissolved into solvent, dimethyl formamide. So we are getting a solution of polyacrylonitrile and dimethyl formamide. Now this solution is filtered and deaerated. And here we have shown both the methods. At the left side, we are showing dry spinning method. And at the right side, we are simultaneously showing the wet spinning method. Because any one method can be used. Both the methods are not used simultaneously. Any one method according to requirement can be used. So if we are going for dry spinning, this solution is passed through spin rate and coming out as a filament into this vertical column where we are passing the hot air. So when we are passing the hot air, the solvent is evaporated. The solvent which is evaporated is taken into the solvent recovery plant, and we are again getting the solvent here, which can be used again to make the solution. And after spinning, after this filament is washed here by spraying the water, and then it is hot stretching is done to make the polymers more oriented towards the fiber axis. Then if we have to convert them into fibers, we are doing crimping and heat setting here. And after crimping and heat setting, cutters are used to cut the fibers into the required staple length. And in that case, in this way, we can convert the filament into fibers. Similarly, if we are using weight spinning, then here we have shown this spin rate, and this is coagulation bath, which is having the certain composition of required chemicals to solidify it, to coagulate it. And then these filaments are, after coagulation or solidification, again wound onto the required package, or it can be converted into fiber form by using the same setup which we have shown in the hot spinning, this dry spinning method. This is all about the manufacturing of acrylic fibers. Here is the comparison between dry and wet spinning method. The fibers which we are getting by dry and wet spinning method, the difference is the fibers which we are getting from dry spinning methods, as far as fiber cross section is concerned, the fiber which is made by dry spinning is having dog bone shaped cross section, whereas by wet spinning, round or bean shaped cross section. The dry spinning denier manufactured is fine by dry spinning and coarse by wet spinning. Polymer concentration is higher in case of dry spinning, that is 20 to 30%. It is lower in case of wet spinning, 10 to 20%. Spinning speed is higher, 200 to 500 meters per minute. It is lower in case of wet spinning, 100 to 300 meters per minute. Finishing process, it is done in batches. Here it is done continuously. Structural characteristics, it is compact and it is microporous. Spin rate size is smaller, spin rate size is larger in case of wet spinning. Polymer solution temperature in case of dry spinning is 80 to 150 degrees centigrade, where it is in case of wet spinning, it is very lower, 18 to 25 degrees centigrade. Hazard potential is more in case of dry spinning, it is high. Hazard potential is low in case of wet spinning method. So in this way, the properties of the fibers which are produced by dry and wet spinning method can be compared. This is the longitudinal this is microscopic view, in which first we have shown the longitudinal view. You can see in the diagram the longitudinal view of 1, 2, or 3 fibers. It is rod-like structure having smooth surface and uniform diameter, and a canal is found in the middle. One canal can be seen in the middle of the fiber. That is longitudinal view of acrylic. It is nearly round in dumbbell shape. That is the cross-sectional view. Physical properties of acrylic: density is 1.16. So it is a low density fiber, lighter weight fiber. Color is natural, means off-white or white color. Tenacity is dry tenacity is 2.5 to 4.5 grams per denier, whereas wet is 2 to 4 grams per denier. Elasticity, it is highly elastic fiber at 2% stretch. It is showing 90% elasticity, 99% elasticity. Moisture regain is very low, that is 1 to 3%. Moisture regain at standard condition. Heat conductivity, it has no effect of heat up to 155 degrees centigrade. Melting point is very high, 330 to 340 degrees centigrade. Effect of sunlight is, it is extremely resistant to sunlight. Chemical properties, effect of acids, no acidic reaction at dilute condition. So dilute acids are having no reactions with acrylic textile materials. The fibers are only attacked by concentrated acids. And there are some spelling mistakes, so please correct it, because I have just taken the pics of the slides made by students. Effect of alkalis, concentrated NaOH and concentrated Na2CO3 attack on the surface of the acrylic, and dilute bases attack and hydrolyzes it. Biology means it is not very resistant to alkalis, whereas it is good resistant to acids. Biological attack, it is very good resistant to moths and mildews. Solubility, it can be, it is soluble in H2SO4, either cold or boiled, HNO3 cold or boiled, phosphoric acid, and dimethyl formamide. Dye affinity, generally basic dyes are used to dye the acrylic textile materials, and usage, it can be used for cheap carpets and manufacturing knitted outwears, flugged fabrics, stubbed pile liners, jersey fabrics, furnishing fabrics, and apparel fabrics. So this is all about acrylic fibers. So with this topic, we have covered our syllabus of 5th unit. So the man-made fibers. So again, reminding you, we have covered viscose from the category of cellulosic regenerated man-made fiber, acetate from the category of modified cellulosic regenerated man-made fibers, nylon 6, nylon 66, polyester, and acrylic from the category of synthetic fibers. Viscose is manufactured by wet spinning method. Acetate rayon is manufactured by dry spinning method. Nylon 6, nylon 66, and polyester can be spun by using melt spinning method. And this acrylic can be spun by solution spinning method, in which wet spinning and dry spinning, both the methods can be used. Thank you very much. So that we have covered 5th unit today. Now the